Blah! Hello. Okay, we're gonna check some stuff because I am running so crazily levels of late. Let's see here. So we got stuff over there, and I'm over here, and you're over there. Good. That is certainly the right idea. Okay. I can admit I am not nearly as prepared for this as I normally would be. So that's not stopped us before, though. Here's what we're going to do. We're going to talk about RFID technology tonight. And then I'm debating if I want attempts to research live? Question mark? On how to hook up this board to the one that we're going to use for our project. Because right now I have it wired on just like the base Arduino. I do want to show you some stuff though, because I at least have a wiring diagram, which I'm going to be real. I don't remember if I actually showed that off last time, but that doesn't matter because that was last time. This is this time. Oh, cries and unpreparedness. Yes, it's fine. At no point has that stopped me before. But yeah, we're gonna do some stuff. So let me. Oh, I don't even have the code up. Hold up, please stand by. While I at least pull the bloody project over. It's fine. It's that time of the year where things happen. And we're doing what we can. I honestly could have had at least a little bit more of this prepared ahead of time, but you know what? Life happens. How y'all doing this evening? Slash morning, slash time zone. You know how it is. Where am I going here? I'm going in here, and I'm going in here. And I need to go... Ooh, that's a good question. I might need to install a library. Yeah, I'm gonna need to install a library. Yeah, it's okay though, we'll do that together. Let me at least get the code over so we can start to play. I say that looking at an empty sketch. Hello? Where's all the code that I had typed? Why did this not open the project? Le gasp! Hi, Thunder. Thank you for the resub. Hello. I am so sorry I started so late. I know you don't do the sleeping thing, but I know it's important. So by all means, when you get the level of EB that you are required to do the sleeping thing, by all means, please do so. Unprepared toaster is unprepared. This did not open. Let's see. Can I do it this way to open this? No, I don't want to link it. Okay, all right, that makes me at least feel better. A 2-hour nap. Good. You are arguably more awake than I am. I'm gonna try this again and see if this interesting. It's not opening the code. Well, that's not good. Yeah, well, it wouldn't be the first time I've done live troubleshooting. Hello, Pine. Welcome on in. Shoot. Well, will this willingly open? Ooh, okay, maybe this did work. Did this work? Okay, compiler's stupid. Got it. That's okay. So I should be able to... Please tell me my clipboard's gonna work. It does! Hooray! I have a clipboard. And it's working. Okay. That puts us in an interesting position. Did I grab the right project? Please hold. I got that. Where's the line of code? Okay, all right. I found the one I was looking for. Fabulous. All right, so I'm gonna close that. I'm gonna close that. I tried properly sleeping, but brain said, you're going away now. Oh, yeah, that's fair. I'm doing okay this evening. How y'all doing? How you doing, Thunder? I spy a Porsche. Hello. Ooh, that's a fun little color. Who's that? VI Hedge Lurk? Question mark? I don't recognize that one. You got a little either little antlers or my eyes don't work. Maybe some combination of the two. And it's fine. Oh. Hi, Humvee. How are you? You've caught me on a really unprepared night. Yeah. It's fine. Welcome on in. I'm gonna nerd out on stream in an appropriate fashion because that's what I do. Oh God. All right, I'll close that. Do I need to know what library this is? I feel like I know what library this is. Yes, I do know what library this is. Solid. Oh, good. I'm glad to hear you're well this evening, / morning, / time zone. Because that's how we roll around here. We're everywhere and nowhere all at once. Alright. I can click buttons now. This is exciting. From a streamer named... Oh, I'm gonna butcher this name. Whitney? Dragon Fox. So horns. Okay, so my eyes do work. Okay, cool. Because I honestly couldn't tell if. Oh, that's much better. It actually, this other lower chat window makes this actually much easier to see. That is adorable. 10 for 10. We've been given a bullet hose. A bullet hose? Interesting. Oh God, glitchy toaster eyes. I can only imagine. Listen, okay? I'm trying, okay? My right hand is a little broken. Don't mind the fact that my hand is going to be in front of my face many times this evening because that's how these hands work. Yes, I know. I don't know what it is because like if they're right here, it's fine. I can cycle through different expressions. I can move my hands. My tracking just turned off. Love that for me. Why? Why did you turn off tracking, you punk? All right, good. Fabulous. The net or VNet? Okay, all right. So I don't know. I struggle so hard with names. I'm so much better with faces. All right, which is fine. Everything's fine. I can at least show you the cool thing that we have though with the RFID. I'm excited to show you at least this because I was tinkering with this for a couple of days. Because I'm gonna be real, this is another sensor that I didn't anticipate having as many leads to it as I anticipated. A bullet hose equals a minigun. Interesting. Still need to get another app. Sell my hand tracking my streams. That's totally fair. All right. We off to a start here. I would say so. First things first, I need to install the library for this code. So let's go do that. This particular code runs off of the no, that's a P. Let's try that again. The MFRC 52. I did not click on the right thing. I need the button below it. I want the library. I want that one. Got you with names. Seriously, like very much Porsche. I know very much that you are a very custom blue and gray critter in VRC. Granted, I've seen you enough times, I remember your name that goes with your avatar, but that's not my point. Avatar faces stick a lot better because, you know, Hopkin, that's the gig. All right, let's see here. Okay. Bluster toaster aside. MFRC522 is a GitHub repository for a library to control the RFID reader that we have plugged into our Porsche. That is a very accurate description of where I'm at right now with my life this evening. And we are going to call on said library. Now, granted, we're going to be using a different microcontroller for the testing portion of this, so I can at least show you because I have it wired and developed to the other board here. But that's okay. So let me flip over to the camera and show you what on earth this thing actually looks like. Why am I on a scrolling stop? How dare. When you're a proto weasel like me, it's not easy to forget. This is true. Actually, that's actually a fair point. Let's see if I can actually make my tab work for me. It does. So, oh, really? Let's try that again. What? What do you mean it doesn't? There's no way. Enter. That's how that's supposed to work. Okay, so yes, by all means, y'all need to check out Humvee, okay? Goes by they, them. Very fun individual to have around. I want to say something right now because they have actually a really unique model. It's a combination of a weasel and a protogen, and it looks super cool. It's funny because I've already told Humvee a couple of times it reminds me of a Tamagotchi by the expressions that show up on the visor. Very unique. I actually haven't seen another model like it anywhere in VRC, and I've seen plenty of them. Nor here nor there. So yeah, by all means, go drop them a follow. They deserve it. All right, I'm gonna hide the library, and then I'm gonna show you the boards. All right, that's what we're gonna do. So I am gonna click some buttons. I'm gonna do the button thing. Yes, I am. I'm gonna go over here. And that puts you guys over there, and that puts me over here. I forgot to turn on the lights. I suppose I should check and see if my microphone's working. Yes, it is working. Fantastic. I at least remembered to turn on the mic pack this time. I didn't remember to do that last time. Okay, so what we have here is the hero board, or the smaller Arduino that we've been developing with on this channel for the last couple of months. The reason I at least started with this is because it's got easily accessible I/O pins, and the other one I'm going to have to figure out how we're going to wire into it. But this is the reader that we're going to be playing with tonight. This is the RFID RC522 developmental breakout board. Now, when you get one of these, they do not come with the pins directly soldered onto the board. So, if I grab another one of these here, you're going to see, I don't know how well this will tell on the camera without me taking it out of the anti-static bag. There's a little bag of pins there. Yeah, that's really too hard for the camera. I don't want to open it because I don't want to get moisture in the board. But the point is that these I had solder on ahead of time, so that we could actually, hook them up and do stuff. Oh, I saw a name. Was that Jesse? Curses my activity feed. Hello, thank you for the follow. Where is it? Why is that not in my activity feed? I love and hate this platform at the same time, specifically in that order. Bloody hell, it's fine. Okay, so we're currently wired up to our board like this, and the way I know we're gonna have a little bit of trouble is once I show you how this monstrosity is currently wired. Because we've got a total of 1, 2, 3, 4, 5, 6, 7, 8 pins. We are only using 7 out of those 8 pins. The IRQ is not plugged in. It's just chilling out down here minding its own business. And then, amongst all of that, only 2 of them are defined in the code. If you hydrate, all right, fine, I'll hydrate. Water, you're gonna make me talk slower, don't do that.
That's absolutely captivating. Yeah.
Secondary channel. Roger. Mighty fine, well, I appreciate the follow nonetheless. Also, Michael the Dragon. Haha, thank you for the hydrate. you make me swallow more than my words. This is weird because we got a bunch of pins plugged in here, but we only defined 2 of them in the code. And I'm going to explain to you why it's going to be a little difficult to figure out how to go from this board to this board, because this is the one we're actually using for the project. We've got, thankfully, this nice little key that explains what all these pins are for. And our controller for the Nintendo Wii is going to plug into this breakout I2C protocol area, which is great. But then we got to deal with these pin headers, and we'll see if we can figure it out tonight. I don't know how difficult this is going to be to attempt to figure out, but what we need to figure out is how to take the pins that we didn't define in the code and figure out where to plug them in on here to make this still work. So first things first, what we're going to be reading is the serial number on these RFID chips. They're stickers. They're black on one side, and on the back is a removable paper. So you can stick these to whatever you want. You can stick them to the back of a business card. You can stick them to the back of your cell phone. Well, actually, lower on your cell phone, because most cell phones can read these because they have NFC capabilities in them. I did call them an RFID tag, but these are the NFC frequency. So if you have an NFC reader built into your phone, or if you download an independent app to use the radio that's built into your device, you can read these, and you can actually program them to do different things. Now, I haven't figured out how to read the programmable area on these, but that's nor here nor there. We just need to read the serial number, and you'll see why. So that's the wiring getup and setup. So for starters, let's actually plug this in so we can do stuff and things. That's going to send power to the board, and that's going to send power over here to our little doodad. And then we're going to define it in the code and do some stuff, because I haven't been developing on this particular computer. I've been developing on a different one, which is why the libraries weren't installed. What fun do we have? Okay, enjoy the Lurk Thunder. We'll be here. I'm going to be ranting. It's one of those kind of nights. I'm feeling it. All right. Where am I at here? I want that one. And my camera has left me. Ring, ring. I'm over here. Thank you. Yep, there you go. There you go. I knew I could trust you, tracking camera. At least so I can hope. All right. Real quick pivot on the music. I tried a different station called The Lounge, and I'm really not feeling it. So let's go back to some lo-fi background music. And then I just gotta turn down the lo-fi a smidge. All right, cool beans. Close enough. Okay, so we have the library installed. I hooked it up. Now what we have to do is connect to the appropriate board, which is not that one. It is too cold outside. You are correct in that assessment. Interesting. So port 3. Oh, hang on. I think I could just tell if it's an Arduino. I think is actually what I should have put in here. See, it's detecting on the last board we had connected, which is in fact the Matrix Portal M3 or M4. But that's not the board we're working with right now. So we have that. There it goes. I knew it was going to do that. I have to switch which board we're developing with so that we can actually read the code or interact with the code we have here. So we're going to go to other boards, and I'm going to search for Arduino, and I want, it's not the Leonardo, that's the one with keyboard support. We're not playing with that one. It's not the Mini, it's not the Nano. Well, if you're going to get snow and it's going to be 30 degrees Fahrenheit, do be careful if you need to travel. Let's see here. It wasn't the Titan. It was the Uno. That's how it was. For that. All right, so I'm gonna verify the code. All right, so that looks okay. And then just to confirm I've got connectivity with the board, I'm gonna push it. This is the sketch I already have uploaded to it, and we're still gonna go through the code. I'm gonna show you why this is a little, one of those matters of attention of why I'm not entirely sure how this is going to go, but again, research, I have to figure it out. All right, so I did push it. It's taking 15% of the storage on the Arduino controller and 15% of dynamic memory, which is interesting. Those usually aren't equal to the same thing. That's just fine. Okay. So before I turn on the serial monitor and I actually show you what this thing is actually going on about, okay, well, if you're doing a trip on Saturday, again, be careful, mind your P's and Q's. If you're doing the driving, throw some cat litter or rock salt in the back in case you get a little stuck in the snow. You could drop that down, get a little traction, have a bit of a better time. It's never fun getting stuck in the snow. Okay, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8 out of the 9 pins are doing something and connected to something. No problems. But what we're going to run into is that we're going to have only 2 pins defined where we're telling it what we're up to. We're defining pin 10 and pin 9. On pin 10 is the data pin, I guess is what I'm going to call it. It's this SDA SS pin. And then on pin 9 is the reset pin, the RST pin. All the other ones have a position they're being plugged into because of the function that they, by default, are hardwired to do on the board. So if we take a look here, pin 13, if you don't define it, you don't set it to do anything, and you plug into it, puts out the source clock of the microcontroller, SCK. Pin 11 is the MOSI interface, and then below it on 12, or technically above it, is the MISO. The IRQ is not defined, which is the pin that is currently the red wire that's not plugged into anything, that's just kind of hanging out in the breeze. That's the IRQ. An IRQ is used to interrupt the code based on an event occurring. Since this is a reader of technology, it's a reader of NFC tags, us putting a tag in front of the sensor will activate that pin. Now, if you plug that pin into something and you listen on it, you can hook up that IRQ to an IRQ interruptible pin on your microcontroller. This particular microcontroller has 2 IRQ interrupts on it. I don't remember which pins they are. I just remember there's 2 of them because we did that with the 30 Days in Space franchise. For what we're doing in this basic exercise, we don't need it. For the big project with the Protogen Head, maybe we will. I don't know yet. But just know it exists. That is its purpose. Since this code is dedicated to reading this, then that's where we are, right? And then we've got ground, which just goes to a ground pin, self-explanatory. The RST pin on 9, like we had mentioned below, and 3.3 volts on our Arduino. Arduino puts out 2 voltages, 5 and 3.3. If we plug it into the 5, there's a chance we damage it. So we have to make sure that we're careful that we don't accidentally plug it into the wrong place. At no point is putting less voltage into something going to cause permanent damage. Usually it'll either not turn on or it'll behave in a strange fashion. Over voltage is dangerous because you're pushing too much voltage through the circuit, which usually causes things to, like, you know, have a bad time. And the magic smokes comes out, which we don't want to do. So we just have to be mindful of that because most of the projects that we've done with the 30 Days in Space on this channel was using the 5-volt rail. This is actually the first project I'm putting out that it specifically requires 3.3. So that we do need to keep in mind. And then from there, the library we installed specifically said we need these 2 includes. We need the SPI and then the actual library we called upon, the MFRC 522. With those 2 together will allow us to interact with the library. Now, a couple things we're going to do here is we're going to create an object so that we can actually interact with said RFID board. So what we're going to do here is we're going to call on the library, and they just called the reader the name of the library, which is okay. We could have called it something different. That's just our class definition of it, and frankly, it's fine. And the only two things this does accept with the example code is these two pins, 9 and 10. The rest of them are assumed based on the way that these other pins are hardwired on the microcontroller. That's the part that's going to be a little iffy. I'm hoping maybe we can find where these particular ones are on that diagram I have printed out and see if we could figure out which pins they go into. If not, it might be a little more research for me off camera. I don't know. We'll see. We'll see where we end up here. Okay, so I'm going to skip over this and come back to it. That'll make more sense once I get to the bottom, and then we'll cycle back up. Like any of our projects, we have a setup section and then the actual loop that runs the code, right? So what we're going to do is we're going to turn on the serial monitor because we have no display, right? We have no display. We have no mechanism connected to the rest of the world to tell us anything in this example. So we're going to turn on the serial monitor, and then we're going to initialize the SPI bus, which is that other library we included. From there, we're going to initialize the reader by calling the PDC_init. And then we're going to just straight up tell the user to put the RFID tag near the reader. So before we've done anything, we've initialized the libraries. And then we asked and said, okay, we're ready. Give me something. Now we come down to the loop. Now, it says that if this is a new card, we return nothing. Or if it's not a new card, that's what the exclamation mark stands for, also do nothing. So right now, these two are not configured to actually do anything. They're just a part of the example code I grabbed. Regardless of whether it's a new tag or not, this code is going to run every time. Now, why did I leave these in here? Because if we take the code that's going to run each time, we could have it so it doesn't spam the chat, or excuse me, the serial monitor, which technically is our chat. But for now, it's just going to run regardless of which tag we put in front of it. Now, the serial number of each tag is unique to the card itself from the factory. With that, we have the ability to actually clone and reprogram certain cards depending on whether they're reprogrammable or not. There's plenty of tools that exist out there that allow you to mess around with these things. Your phone can certainly be one of them. There's a nice app in the App Store that's called NFC Tools that you can use to read existing tags, reprogram, clone a tag. So understand that even though the serial number of the chip is unique, it absolutely can be cloned and you can make multiple of it. So if you're using this for any kind of security purpose, do keep that in mind. There are door controllers that work off of RFID tags, not specifically the ones we're playing with, but the ones that look more like, ID cards. Those work at different frequencies, but the concept is still the same. Okay, so this is where things get a little complicated with reading the tags. Because instead of it just being a very simple string of numbers and letters, the serial number, or the UID, the unique identifying, it's the unique identifier, I don't remember what the D stands for, is stored in bytes. But we don't see the world in bytes. We see the world in ASCII, A through F, or A through F, A through Z, 0 through 9, right? But when stored in bytes, we'd want to convert it into something we physically can understand with our eyeballs. which is where hex comes in. Hex is going to be that bridge to the gap. So us take the byte, convert it into hex, and then we're going to dump all those individual pieces of the screen. And then from there, we can then, based on the number, or excuse me, based on the hex values, we can then toy with it. At no point can you... Bad train of thought. At no point is it a problem that it's stored as a byte, because you could do a byte by byte comparison. But to make things a little easier for our own eyeballs, I'm going to show you how we're converting it to hex, and then we can actually do something useful with this, and how I want to integrate it with the proto. So right here we can see that this isn't a simple just read it. It goes byte by byte to bring out the entire unique identifier. So this loop gets the full size of the UID, and then it loops through each section of the UID. Think of it like a bunch of Tupperware containers that are lined up side by side by side. So you have the first container, the second container, the third container, so on and so forth, right? And then we're going to print to the screen the byte value in hexadecimal format. Hexadecimal format is going to be A through F, 0 through 9. Both of those combined gets you hex. And then from here, we just print a blank line. And then we're going to run some logic down here. Now, I mentioned back at the top, I skipped over those 2 lines. This is where they're going to be relevant, because I'm doing something stupid with this code, right? As I had mentioned, there's a unique identifier that are in these tags. And this right here is the entire byte value for both of those little cards I just showed you, stored in hexadecimal format. Hexadecimal format from byte value to hex is going to be 2 characters. So this 04, 4D, 9E is the hexadecimal, but to store all of these hexadecimals inside of a container that's no larger than a byte worth of information, we have to do it with this 0x, which is just a formatting thing. I'll be real with you right now. I don't remember which of those is which. All I know is that I stored both of them, and they're both unique, because we're going to have the terminal show us something different depending on which card we put in front of it. So back down here, if the card is the quote-unquote authorized UID number 0, we're going to say a woo. Or if it's the authorized UID 1, we're going to look shocked. Like yes. So that's what we're going to do. It's going to, when we put the card in front of it, it's going to run one of those 2 things. Now, granted, in both cases, it's going to say that it's an authorized tag first, because the example I was working with was for a pretend security system. And I figured that's fine. As long as I could add my own thing in here to understand what on earth I'm doing. That's how we get away with it, trying to understand what we're doing. Plus, I figured as long as I leave that in there, I'll remember why I have what I have in here. Because at the end of the day, the full production code that I would put into the Proto Head is not going to include the extra crap here that I have, but it helps me understand the difference. That's important. So as that goes, we then have a bunch of stuff that I have commented out here. Now, I left this here because A, I did not have time to clean it up before I copied it over here. But more importantly, B, something I did want to mention. I did spend some time trying to read the serviceable area of these cards. I don't know how to do that. I'm gonna be real with you. It's a mess. Because the data is stored across multiple sectors that are broken into blocks. So you have to be able to find the correct sector, the right block, and then the right block chain to then convert that from byte to hex into ASCII. It's a nightmare. It's a genuine nightmare. I spent a couple of hours on it and got nowhere. To be honest, I'm sure if I put enough time into it, I'd figure it out. But for right now, I'm not worried about it because what I want to accomplish, I have in front of us. I can differentiate between the different cards, which means I can make the code do different things based on what physical thing I can put in front of the reader. So with enough of those words out, that's all the code that's going to make this example work. So I'm going to turn on the serial monitor and I'm going to show you what happens. Once I remember where it is. Haha. Okay, so I can tell you right now that since we were working with a different board that runs at a different clock speed, we need to adjust the baud rate back to 9600 baud, and then I'm going to clear the monitor, and I'm going to reset the board by hitting the reset button. And then clicking the little button, boop. We should have words. Yeah, yes, the readable kind. Isn't that exciting? I like being able to read my code. Let me tell you right now, when you play with any kind of this stuff and typing, what's essentially, you know, the bridge between machine language and you, it's a little easy to get lost. But leave yourself breadcrumbs. You'll thank yourself later. I know I'm thanking myself right now. Because not only did I immediately recognize that I was running at the wrong speed down here, it's right here. I told it how fast I want to go. That's how I knew what the baud was supposed to be. And that's just simply the communication between the board we have plugged in and my laptop. Okay, so now I'm going to take the first card. That I have right here, and I'm going to put that in front of the sensor. Okay, so this is the AWOO tag, and it told me a couple of things. It spat out to the screen the unique identifier that we have stored right here. So what we did is we did we did a comparison, right? And this is why coding sucks sometimes, because the concepts can get deep in a hurry, but this is the way I'm gonna explain it based on how the way I understand it. We did not compare the entire length of this in one go. That's not what the comparison does. What the comparison does, which is this section right here, this right here, this MEMCMP. Check this out. The MEMCMP function compares the first LEN bytes of the memory areas S1 and S2. It's a comparison function that performs using unsigned char operators to return basically whether the sections of each memory equal to each other. That sounds like garbage, hot garbage. The way I understand it is that you take the first chunk, because again, it was a loop, right? It didn't read one big thing, right? That's why there's spaces between each of these here, because within the loop it added a space. So it took a look at the first two characters that were converted from byte into hex, and then it looked in our stored variable, because I told it specifically to look at the first one and to look at the second one, and if it matched either of these, then it spat out the respective character and the wording that it's an authorized tag, because that's what we saved in the code. Hi, Hobbit, welcome on in. So it looked at the first two characters and went, okay, that matches.
Bob, can I get a glass of water?
Cheers to that. Everybody else in chat, drink something liquid, preferably the water kind. I've got hot tea, that works too. Okay. Thank you for the hydrate. Yeah, we looked at the first two characters, and then it's a pointer. It literally looks inside of the first position of our byte array, because this is an array of hexadecimal values. Talk about being nightmare shaped. My goodness. But all we do is a pretty simple comparison, and we point and we look at the value that we have and the value that we have stored. It's pretty simple, but it's a pointer. It's not a it's confusing because it's not actually converting anything per se. It just looks at what we have stored and then see at the byte level if it matches. I believe that's the way that that's explained, because it says that it's an unsigned comparison. So if you stored signed variables and you're comparing with this function that works in an unsigned nature, I don't think it would work right, because it comes down to the thing of what goes in must match what's going to come out on the other side. So if you're talking English on one side of the communication and the other side is speaking Dutch, there's no communication there unless there's something to convert between the knowledge, between the languages, right? If somebody can speak English and Dutch, well, then that's converted, right? But if somebody's speaking English, someone's speaking Dutch, and neither of them understand the other language, there's no communication, which either means you get results that don't make any kind of sense, or no communication happens at all. In the case of this, we're matching apples to apples, hex to hex. And that's important, because if I stored this in a different format and the comparison doesn't know that, then it's not going to work right? So this tag that I have in my hand is the awoo tag, and I can stick it back up there, and it's going to cycle back through this with a pause of about a full second. And then I'm going to grab the other tag, and I'm going to put that on there, and we're going to have a different serial address, and now we're looking surprised in our terminal. We got big eyes, right? How does this incorporate with the proto? Okay, so here's the rundown, right? What I want to do is I want to incorporate this reader somewhere in the front of my jacket so that tag, right, prop has tag in it, whether that be a plushie stick of RAM, a plushie of some kind, I don't know, something small that I could retract, essentially, that you could just tap against my jacket and then make the facial expressions on the visor change based on which tag you used, right? I'm gonna be real with you right now. I already know that the screens are going to be pretty basic, but I'm planning for the future, because if we can figure out the hardware side of the way that this needs to look right now, figuring out the code that's going to make the animations happen and the other functions, we're already prepared for. Because sure, you can introduce more hardware later, right? But if you incorporate the hardware that you plan on using later now, then it becomes incorporated into the design, and then you can actually run off into the forest with it and make something useful. That's, prepared for future you, not current you. Because current me knows that I want to incorporate the existence of these tags, because I think that's a pretty cool idea. Because how awesome would it be to have an interaction where you hold up a little plushie stick of RAM and put it somewhere near the Protogen, and then the expressions change? How awesome is that? That sounds awesome. That's kind of the direction I want to go with this. And being able to identify the difference between the tags, right, could simply mean based on which tag I now know the difference, show a different expression. Maybe it shows like a chewing animation, for a stick of RAM versus, the eyes turning into hearts for it being maybe a little plushy heart. I don't know, something in that regard. It's kind of the thought process I'm having here. Now, the reason I mentioned that I said that it's hard for trying to read the data section of these tags is because, well, A, it is, and B, I thought it'd be kind of cool to incorporate the ability to like store someone's like business card or social card using the reader that would be a part of my, Protogen Head. But I am pushing that well out of the scope of this project, at least initially. Maybe at some point in the future after I've built the Protogen Head and maybe I'll understand the library a little bit more. Maybe I won't. Maybe that could be something that could be added later on. But for right now, I simply want to be able to read the difference between tags, which we figured out how to do. And now we can do something different based on where we end up. The code and what you do with it looks pretty boring, more or less, when it lives in a terminal. But when the action's figured out and you can control other things in the actual real world, that's when things start to get cool. And right now we're in that developmental stage of figuring out, well, how to do just the simple basics of determining the difference between one thing and the other. So far we've been able to figure out how to read the data on our controller. And now we have an idea of being able to read tags, differentiate from them, and then later on being able to tell it, all right, well, if it's this tag, do this thing. Now, the next part that needs to be figured out is how this reader gets hooked up to our actual board we're planning on using. I have full confidence that it can work because they both work off of the similar compiler. And a lot of these chips, this one just so happens to be a beefier chip of what we currently have plugged in. So there's likely these same protocols and pins that we can work with. And the question is, what's that going to look like for us? So what I'm going to do is I am going to put, I closed it over there, but that's okay. What I'm going to do is I'm going to grab this stuff. And I'm going to put that over here where I can see it. And then, let's see here. What I want to do is I want to pull up the diagram so you guys can see the full image. Which I'm pretty sure I had saved it. I gotta look for it though. Let's say I threw that in the pictures folder. I did. Look at me go. Okay, cool. So you guys are now looking at what I'm looking at. I've got a paper version of that right here. And what I want to see is if we could figure out what pins have to get plugged into what. Now, for the programmable pins, I'm not really worried about figuring out those because if it's programmable, that means we could choose whichever pins we want, as long as it supports the function that we need. What I mean by that is that on our existing board, we have a bunch of digital pins, but only some of them support PWM, which stands for pulse width modulation. I don't know if this library specifically requires that, because it doesn't say that in the notes. But we did use some pins that are both. So I'm actually curious to see here. If we look right now, we can see that we've got GPIO, power domain. Yeah, some pretty wild stuff here. And what we currently have to figure out, we know that the RST pin and the SDA pin are programmable. Now, in the example, it said specifically a digital pin for pin 10, which is the SDA line, which should mean any of the pins that are already marked down here as just being regular GPIO should be fine. Now, let's see if we look at this, if we could determine if what we have is just in the diagram or not. So the first thing we need to see if we can find here, we're going to play a little bit of a scavenger hunt here. And then I am looking at the matrix portal. I'm just typing off screen here just so I can, you know, go through this one at a time here. All right, so the source clock, or the SCK, if we look down here, I see that the GPIO pin is the MTX CLK. That's promising. That's probably what we're looking for. Because I don't think any of these others specifically say SCK. I love this NeoPixel that's built in. It's so cool. It's like this multicolored LED that's like a part of the surface of it. I'm so happy they include the pin numbers for these. I was kind of wondering how that worked. The reset is reset. There is no argument there. Right, now obviously I wouldn't want to have to involve any of these, but if we look here, oh yeah, SCL. That's a data line. Okay, so I have decent confidence then that looking at this, that the SCK is going to get plugged into GPIO 2. All right, cool. That's one down. Next one to go is going to be the MOSI. No, I do not think we would get lucky enough for it to just be labeled that here. So, with that being like that, the MOSI, we got these address A and C. I'm not sure what those are about. It's funny too because the diagram that I worked off of for the example, and a part of why I plugged it into the board that I just showed you, is because it gave me the wiring layout. But the reality is, as long as you can find at least a starting point, then you can, you know, work on flipping it, which is what we're attempting to do right now. All right, so ground is easy. I already know that ground is going to go to ground. That's not that big of a deal. Are any of these actually grounding pins? Because it's looking like, yeah, we do. All right, cool. So there is a ground pin, and it's labeled ground. So we do, in fact, have one right here on the connector. Which, oh, there we go. I wasn't clicked. You couldn't see me moving the mouse. So we have that one there. We have the clock pin down here. I'm not worried about the IRQ right now. And we're going to have to look at the data sheet for this, if we need that, to figure out where that's going to have to get plugged in. I'm under the hopes that everything we need will be here into this header. Oh, by the way, this is just a breakout of this section of the board. This is just to make it a little easier instead of because of the way the graphic is laid out. But I'm kind of the mind that everything we should need would be down here, I hope. Well, let me take a look here and see if I could locate what would be the comparative pin. So right now we're looking at the Adafruit matrix portal. MOSI pin. Interesting. So this is telling me what? Let's see, circuit pins in Python. Let's see what this has to say. Now I can tell you I purposely bought 2 of these because this one had built-in Bluetooth into this chip, which is what this little squiggly line is. That's the radio antenna. Because I needed this board to be able to communicate back to the main microcontroller that's going to control the face. Which means I'm going to attempt to use this very specifically laid out board, not in its intended fashion. Because this was designed to just be plugged into the back of a display, which I don't want to use it that way, because again, these are programmable pins. I should still be able to get away with what I want to do, just maybe not in the way I'm thinking it will need to be. That part I haven't figured out yet. Could it be possible that we might need to involve a individual microcontroller just for this, and then plug that into this microcontroller to then send the data back to the other one? Maybe. I don't know yet. We'll see. And when I mean microcontroller, I'm talking about just a little chip. You know, if we absolutely have to develop something with the pins, we will. I'm hoping it doesn't have to get that complicated, but then again, this is a complicated project, so I don't know. We're going to learn along the way. I'll tell you right now, that's what we're up to. Because I'm really hoping someone could tell me the following pins have labels on the physical QT board: AIO, blah, 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 source clock, transmit, receive, source clock. You'll see there are many more entries available in board than the labels on the QTPY. Am I looking at the right board? I am looking at the right board. Yeah, no. I love that. The Google AI results were just bullshit because the documentation says, yeah, it has that. I can't express to you, okay, how unbelievably angry the AI results are when they say, oh, it doesn't do that. And then I look at the documentation. It's like, oh, it does do that. You just have to plug it in here. The frustration station. We are there. Okay, let's see. All right, if this is claiming, then right, IO class AO0, 1, 2, 3, 4, 5, debug, I2C, yeah, MISO, MOSI, NeoPixel, receive, source clock, SCL, STA. All right, let me get the board in front of me because maybe I'll actually find what I'm looking for printed on the board. So yeah, let's do that. I'm no stranger to doing a little bit of investigative work. That's how we've gotten this far. All right, so to make my life a little easier, I'm going to disconnect the controller from the microcontroller right now. Because right now I'm not planning on plugging this in as of right this minute. So what we're looking at is this microcontroller, and this is that section that I'm looking for us to be able to stick into these pins to be able to make the marriage between this piece of equipment and this piece of equipment. And then we already have the dedicated port over here for that, the Wii controller that we're going to plug in there. So I'm hoping that we plug thing in here, thing into the top of here, and then, you know, we're off to the races. Because this area right here is pre-programmed, and funny enough, it has no headers. This is what I meant when I had to put the legs on this. That's what I was talking about. Because even this one has a section here where you can add pins, but they're not there by default, which is fine. But if you need them, then, you know, you end up in the position we're in right now. All right, well, there's no labeling on the back. And the documentation I'm looking at does not appear to line up with any printed labels on here. And the connector doesn't have anything embedded in the plastic that my camera can't pick up. Which, the answer to the question means we should still be able to figure this out. It's just, it might be a little roundabout in the way we get there. Which again surprises no one, including myself. Alright, so note, the most of the pins are named in an IO style, such as 0, IO1, IO2. Those pins on the physical board are labeled only with a number, so an easy way to know how to access them in CircuitPython is to run those commands in the REPL and find the pin naming schema. If your code is failing to run because it can't find a pin name you provided, verify that you have the proper pin named by running the command REPL. Now granted, that's in a different programming language, so that doesn't quite line up with what we're doing. We also see there are often, but not always, 3 special board-specific objects, including the I2C, SPI, and UART. Each one is the default pin set used for each of the 3 common protocol buses and their names. All right. All right, so what we're looking for... Okay, so those pins... All right, so we actually have some action here. The pins that we have plugged into our board under the general assumption of being in the right place falls under the UART protocol. The MOSI, the MISO, and the SCK, aka the source clock, are all plugged into a default bus. Check your board documentation pinout for the default buses. Oh, that's cute. I'm looking at the diagram and it don't tell me. I would love that information. Care to share? Here's the result when the script is run. Ooh, okay, I might have found it. Each line represents a single pin. Find the line containing the pin named that's labeled on the physical board, and you'll find other names. Interesting. So board. PA06. Right, because we've got GPIO numbers down here. Now I'm looking at the documentation on Adafruit's website, so I'm not in just some random form. This is directly from the manufacturer of what I'm looking at. And if this is claiming the source clock is PA11, do I have an 11 down here? I do not. But I do up here. Could it be that what we... Oh, wait, hold up. U1R... Nope. Shoot, I thought that was UART, which is what we were looking for. Because again, the I2C, which is that tiny connector I showed you, is where we plug in the controller. And it uses the I2C protocol. Or the I2C, as some people call it. I don't know. I can call it either or, I think. I'm probably wrong. I'm probably supposed to call it the other thing. Oh, look at that. There's another source clock pin inside of that other dedicated header. All right, well, let's check this out. So GPIO 11 is SCK for source clock, according to what I'm looking at. MISO is PA09, which would be here. And then we have an SDA and SCL, 16 and 17. Which is these two up here. Okay, that actually would make a little bit of sense. Because when you chain multiple I2C devices together, they do share the same set of wires. Even if it's not in a dedicated connector head. But I'm going to tell you right now, that's going to cause me a little bit of trouble. Because I was kind of hoping we can use the pins that are down here for that. I'm not shy of soldering on some additional 90-degree adapters on here for us to use these pins. I actually just so happened to have purchased a couple of pin packs just for the occasion in case I needed them, which I might end up actually needing them. So yay for foresight. Because we need SCK, which is 11, MISO, which is 12 on that board, which is 9 on this board, which is here. SCK. All right, so if I could get away with using the source clock from this GPIO2, which would put me in this position right here. If I use that one, and then pull the MOSI and the MISO from over here, then I shouldn't have to disturb the source clock pins up here. As long as these are both clocking pins, this one down here, GPIO2, I actually should be able to make that work. All right. Oh, that's exciting. Before I solder anything onto this board, I am going to verify that though. So we are going to test that tonight, but I think we've at least found a direction we can head in with this. This should still be able to work the way I want it to. And then of course, this whole thing runs on 3.3 volt logic, which is fine. There's a pin right there for it. It's dedicated. I'm not worried about that. If we look down here, these are all data pins, so I wouldn't be able to pull from down here. Now, like any other board, there is a ground pin down here, and there's like several of them on the board. Any of these grounds that are open are fair game. So I can use the ground that's in this area the same as I would on this dedicated connector or this available header pin. All of them would work all the same because all the grounds are bonded together. Same thing with the one up here. So that gives us, I think that gives us our direction, which is exciting. Cool beans. All right, I like that. That gives us actually somewhere we can go. Cool. All right, so we have the logic for that. We still have to figure out how to make the two boards talk to each other, but that's going to require some off-camera work, so I can find the correct libraries, because that I've done it before in an offhand project that hasn't been on my platform before. So I know that the libraries aren't impossible to locate, but I need to see how we specifically use one that's built into the microcontroller. That part's a little different, but I've done the same logic before. I did something along the lines of a hello world, where one board would just constantly say hello world, and then on the other board it would just spit it to the terminal and say hello, how are you? I'm fine, thanks for asking. You know, that kind of whole interaction, which is super fun. All right, cool. I like that. I think that's about what we're gonna do though. So I'll get that verified. Once we have that verified, then nope, that's the wrong finger. Once we have that verified, then we can get this integrated, combine the code, and then spit out the unique identifier of our badge. And on top of that, read the controller data all from the same board. And then from there, we have to send that information over to the primary microcontroller where the screens are going to be. And then we also have to figure out the screens, the animations, working with them. Thankfully, the pinout is going to be really easy because it's literally take this hunk of computer wizardry that I just showed on camera and plug it into the back of the screen. So I'm not too worried about making the screens work, at least yet. I haven't even powered them on yet, so I'm not really sure what our challenge is going to look like for that. But I can tell you that this is decent progress, at least. I'm pretty happy with this. Yeah, I like that. All right, cool. So let me take a look here. I'm going to get some documentation in my notes for future techie to be able to figure himself out. Because that's how I roll. If I didn't document, I'd be sad. And if I'm sad, then you're sad. Watching the sad. No one wants that. I know I don't want that. That's no fun. All right, cool beans. So with that, that's not the right command. All right, cool. So that's going to conclude tonight. I believe for the next stream, we're going to do a game. I did get my hands on the game that was recommended to me. I love that my smart speaker chirped up. I love that. I want to say Pine recommended it to me a while back. It's an old school game called The Day of the Tentacle. It's like an old school side scroller looking kind of game. Like I've played Pajama Sam on this platform. Putt wasn't you? Well, if it wasn't you, maybe it was Pyrex then. I'm remembering the username at least began with a P. Yeah, it had to have been him then. Well, it looks cool. And that's something that we're gonna play some on the platform here. It sounds like it was fun, and Steam had this ridiculously discounted price on it. I got it for like $1, so I saved like $20 or something. I don't know. It worked out. So we're gonna cycle through games, more of this stuff. You know, I'm gonna do the toaster thing. Yeah, right. It's a good old Steam sale. Now your wallet might have a bit of a disagreement on how it feels about that, but you know, for the rest of you, it feels pretty good. So with that, let me take a look at my calendar here real quick. Yeah, all right, so I should be back for next Wednesday. Weather depending, I'm hoping I won't be this late again, but we'll see. On the early side, I start around 7. On the late side, I start around 7:30 Eastern Standard Time. But yeah, I'll be back, and then we'll do more fun stuff. I am looking forward to the additional progress and working through the code I find, the code we're working off of, the code we build, and hell, just building this thing in progress. Because right now we're looking at the very low level side of the project. We haven't printed any of the 3D files to make the visor base. There's going to be a whole lot involved in this project. I'm very much here for it. But you got to start somewhere, and I figured figure out the electronics first, and then once we have those figured out, then we'll work them into the process of figuring out how they're going to fit into the head. And then at the end, we're going to have a Protogen head. There's a lot that's going to be coming for this, and it's going to be a bit of a slow roll as I work through it, because frankly, there's a lot to figure out, as you can clearly see. But that's okay, because this gets to take as much time as it needs to, and I want to do it right the first time. So that's what we're going to go with. So with that, we are going to conclude here, and we are going to raid into It's Maple Dough. Let's see what she is doing. I think she's doing art. Oh, is it art? Yeah, it's art. All right, cool. So Maple is doing arts and crafts this evening. If I remember correctly, Maple's commissions are still open. And she did an absolute stunning piece for me of this particular Protogen in stained glass. ask her about it. I'm sure she probably still has it somewhere floating around. If you want to see the super cool artwork that she has put out there, I know she puts it up on her socials. And frankly, she is adorable. So yes, adorable. I know what I said, and it's okay. With that, I've said too many words. I wish you all a fantastic night /time zone. And I'll catch you on the next one. And with that, good night. Bye-bye.